In this EZEd video lecture, we are going to learn Introduction to Functions and the need to define a user-defined function. Also, we will cover various categories of functions, namely, function with no arguments and no return values, functions with arguments and no return values, function with arguments and one return value, function with no arguments but return value, functions that returns multiple values. Let's start with understanding what are functions first. We can divide a long C program into small blocks which can perform a certain task. Function is a module or block of program code which deals with a particular task, and each block is self-contained. Making functions is a way of isolating one block of code from other independent blocks of code. Functions serve two purposes. Firstly, they allow a programmer to develop modules independently of other modules. Second, they make a block of code reusable, since a function can be reused in many different programs. A function is a block of code that has a name, and it has a property that is reusable. The name of the function is unique in a C program and is global. It means that a function can be accessed from any location within a C program. C function is divided into two following categories: library function, user-defined function. A library function is one which is not required to be written by us and is already stored inside the library. Examples of library functions are main, printf, scanf, sqrt, etc. A user-defined function is one which is developed by the programmer while writing the program. This function can later become a part of a C program. Moving on to the need for writing a user-defined function. As we know that main is a user-defined function, and every C program should have exactly one main function which indicates where the execution of a program begins. We can write a program with only one main function, but the program will become too large and complex. Also, debugging would be a difficult job. Thus, to make this easier, the program can be divided into smaller functional units which can be programmed separately and combined later on into a single unit. These independently coded units are subprograms. In C, these subprograms are called as function. At times, we are needed to repeat certain type of operations a number of times. This is done by writing the code a number of times in the same program. This is a tedious job, and it is unnecessarily increasing the complexity of the program. This problem can be sorted by writing the operation in a function and calling the function as much number of times as needed. The advantages are: it facilitates top-down modular programming. The length of a source program can be reduced by using functions at appropriate places. It is easy to locate and isolate a faulty function for further investigations. A function may be used by many other programs. This means that a C programmer can build on what others have already done, instead of starting from scratch. Now let us learn Multifunction Program. A function in simple terms can be viewed as a black box which takes in some value if required as input and gives the result as an output. The internal details of the function are hidden from the rest of the program. Every C program can be designed using a collection of these black boxes. Consider this example. DisplayName is a user-defined function here. Above functions can be used as follows. This program consists of two user-defined functions, namely DisplayName and main. Firstly, the printf statement in the main program is executed. This is followed by the call to the user-defined function DisplayName. This will transfer control of the program from main function to DisplayName function, which results in execution of the statements within the body of the function. As there is just one line in the program, the control is transferred back to the main function. The execution continues from the point the function call was made. Now, as there is no statement after the call statement, the program ends here. This is the output of the program. In a program, any function can call any other function. It can also call itself, and also a call function can call another function. This is how multifunction programs are. Main function calls function 1 after the execution of function 1 control is transferred to main function again, after which function 2 is called, which again calls function 3. After executing function 3, the control is transferred back to function 2. Then the rest of the lines of function 2 are executed, after which the control is transferred to main again. Again, function 1 is called here.
Hey, it's time to concentrate now.
Let us learn the elements of user-defined functions. Functions are type of derived data types in C. We can define functions and use them like any other variable. There are similarities between a function and a variable. A function name as well as variable name is considered as an identifier, and so they should follow the following rules of the identifier naming. Function and variable both have a data type associated with them. Function and variable names must be declared and defined before they are used in a program. In order to use a user-defined function, three elements that are related to the function should be considered: function definition, function call, function declaration. The function definition is a module of code specifically written to implement a task. While in order to use this function, we have to invoke the function at the right place. This is called as function call. The program or function that calls a function is called as the calling function, while a program that is called is termed as a called function. The calling function must always declare a function which it will use later in the program. This is called as function declaration. All the functions must be declared before they are invoked. A function declaration, function prototype, consists of four parts: function type, function name, parameter list, terminating semicolon. This is the general form. This line is very similar to function header except for the terminating semicolon. Equally acceptable forms are when a function does not take any parameters and does not return any value, then this is its prototype. The prototype can be placed at two locations in the program: above all functions, inside a function definition. When the prototype is declared above all functions, then it is called as global prototype, and so all these declarations are available to all the functions. When it is placed in a function definition, then it is called as local prototype and is available for access for only that function. The place of declaration defines a region where the function can be accessed by other functions. This region is known as scope. Now we learn return values and their types. A return statement is used to return a value to the calling function. The called function can return only one value per call. This is the general form. This return statement does not return any value. When the return statement is encountered, the control is transferred back to the calling function. The second form of return with the expression returns the value of the expression. The last two statements can be combined into one statement as this. A function can also have more than one return statements. All functions return integer type of data by default. We can force a function to return a value of a particular type by using a type specifier. When a particular value is returned, it is automatically casted to the return type. The functions which perform computation on float and return int type, the values are automatically truncated to an integer. This function returns the value 7 as only that part is reserved.
Seriously, pay attention. This is important.
Let's move on to studying how a function is called. A function is called by simply using the function name followed by a list of actual parameters, if any enclosed within the parentheses. When a compiler encounters the function call, it transfers control from the current statement to the function definition. In the given example, the control is transferred to the add function. The value of x is assigned to a and value of y is assigned to b. The function is then executed till its last statement until the return statement is encountered and the value p is returned to the main function assigned to z. There are various ways in which we can call a function. We can place the actual arguments or the constants or a combination of them or another function call or expressions within the function call. When an expression is used in a call, it must be evaluated to a single value in order to pass it in the call as a parameter. A function which returns a value can be used in any expression like other variables. However, add a b equals 12 is an invalid statement. Moving on to function definitions. It is also known as function implementation. It includes function name, type, parameters is combined into function header, while local variables, function statements, and return statements are grouped into function body. The general format is: the function type defines the type of value a function is going to return to the calling function. If return type is not mentioned, then C will assume it to be of type integer. If the function does not return anything, then the return type is void. Function name should be a valid identifier name. The name should be appropriate to the task it performs, and care should be taken that there are no duplicate names. Parameter list represents the list of variables that will receive the data from a calling function. They are input data to the function to carry out a task. Since they represent actual values, they are termed as formal parameters. The parameters are also known as arguments. It consists of declaration of variables separated by commas and surrounded by parentheses. Examples: int mul, float a, float b. Note that there is no semicolon after the declaration. The function need not allow to receive values from the calling function. That time the function has no formal parameters, and to indicate any empty parameter list, we can place void keyword in the parenthesis or keep the parenthesis empty. The body consists of local variable declaration, function statements that perform a task, return statement. If the function does not return any value, the return statement can be omitted from the body. Here, mul is a function of type float and has two parameters a and b.
Hey, it's time to concentrate now.
Let's learn the various categories of functions. Category 1. Function with no arguments and no return values. Category 2. Functions with arguments and no return values. Category 3. Functions with arguments and one return value. Category 4. Function with no arguments but return value. Category 5. Functions that return multiple values. Let's discuss each category with examples. Starting with the first category, no arguments and no return values. When a function has no argument list, it means that it does not receive any data type from the calling function. Also, when the called function does not return a value to the calling function, then the calling function also does not receive any data from the called function. Thus, in this situation, there is no data transfer between the calling function and the called function. Let's write a program to illustrate these type of functions. We start by declaring the names of the header files. Then we declare the prototype of the function. As the function has no return value, it is of type void, and also as the function receives no data, so there is no argument list. Then we declare the main function and write a function call to the function area, after which we end the function with getCH function. Now we write the definition of the function area. Note, definition is same as declaration except for the semicolon. As the function calculates area, we define two variables, rad for radius and r for area. We ask the user to enter the radius and save it in rad using scanf. This line calculates the area using the area formula. Finally, we print the area. Moving on to category 2, functions with arguments and no return values. These types of functions receive the arguments from the calling function, but they do not return any values to it. Thus, there is only one-way communication between the called and calling function. The above area function can be modified in this way in its prototype declaration. Similarly, the function call would also change. The actual and formal arguments must match in the number, type, and order. The values of actual arguments are assigned to the formal arguments on a one-on-one basis, starting with the first argument. In case if the actual arguments are more than the formal arguments, then the extra actual arguments are discarded. While if the actual arguments are less than the formal arguments, then the remaining arguments are initialized to garbage values. Write a program to illustrate these types of functions. We start by declaring the names of the header files. Then we declare the prototype of the function. As the function has no return value, it is of type void, and as it is receiving radius as an argument, so we add it in the argument list. Then we declare the main function followed by the variable radius. We ask the user to enter the radius and save it in the radius using scanf. Then write a function call to the function area, after which we end the function with getChFunction. Now we write the definition of the function area. Note, definition is same as declaration except for the semicolon. As the function calculates area, we define a variable AR for area. This line calculates the area using the area formula. Finally, we print the area. Next category is functions with arguments and return values. The function area receives arguments from the main function, but it does not return any value to the calling function. It displays the area in the area function itself. We may want the result for further processing in the main function. Moreover, to ensure portability, the result should be handed over to the calling function so that it can display it in the way it wants to. Different programs may require outputs in different formats. So in order to serve this purpose, the function must return the value to the calling function. Thus, a self-contained function behaves like black box that receives a predefined input and also returns a desired output. Such functions have a two-way communication. Write a program to illustrate this. We start by declaring the names of the header files. Then we declare the prototype of the function. As the function returns the area of the circle, which is of type float, so the return type is also float, and as it receives radius as an argument, so we add it in the argument list. Then we declare the main function followed by the variable radius and area1. We ask the user to enter the radius and save it in radius using scanf. Then write a function to call the function area. The area which is calculated by the function is saved in the variable AR and displayed using printf, after which we end the function with the getChFunction. Now we write the definition of the function area. Note, definition is same as declaration except for the semicolon. As the function calculates area, we define a variable AR for area. This line calculates the area using the area formula. It returns the area to main here. Finally, we end the function. As we can see that the output has not changed, but the place where we have placed our printf function has changed. Moving on to category 4, functions, no arguments but returns a value. At times we are needed to design functions that do not take any arguments but returns a value to the calling function. A typical example is that of getChar function, which accepts no arguments but returns the character entered by the user. We can change the area function accordingly to accept the radius of the circle inside it and return the value of area to the main function where it is displayed. Now let's write a program to illustrate this. We start by declaring the names of the header files. Then we declare the prototype of the function. As the function returns the area of the circle, which is of type float, so the return type is also float, and as it does not receive any data as an argument, so we leave the parenthesis empty. Then we declare the main function followed by the variable AR. Then write a function call to the function area. The area which is calculated by the function is saved in the variable AR, after which we end the function with getChFunction. Now we write the definition of the function area. Note, definition is same as declaration except for the semicolon. As the function calculates area, we define a variable AR for area and rad for radius. Then we ask the user to enter the radius and save it in rad using scanf. This line calculates the area using the area formula. It returns the area to main here. Finally, we end the function. Last category is the function that returns multiple values. Till now, we have only studied functions which return only single value at a time. This is because the return statement can return only one value at a time. However, if we want to get more information from a function, then using arguments that can send as well as receive multiple information from the calling function can serve our purpose. This is achieved in C using the address of AND, an indirection operator. This involves the concept of pointers, which will be covered in the pointers topic. Moving on to nesting of functions. C permits a function to call any other function, which then calls another function. This is known as nesting of function. There is no practical limit as to how deeply the functions can be nested. Now let's learn what's recursion. Chaining occurs when a called function in turn calls another function. Recursion is a special case where the calling function calls itself. One of the instructions in such function is a call to the function itself, usually the last statement. In some ways, it is similar to looping. This will display high continuously. To stop the execution, we will have to break the program and terminate the execution abruptly. Another example is of calculating factorial, in which the product of previous digit factorial is the input for the next digit's factorial. Let's calculate factorial of 4, which is 4 multiplied by factorial of 3. While factorial of 3 is 3 multiplied by 2 factorial. Similarly, 2 factorial is 2 into 1 factorial, which is 1. Thus now we go in reverse direction. So we replace the factorial signs by values. Thus the factorial of 4 is 24. Now let's compare the three ways of finding factorial. One is using loop, second one uses a function, while the last one uses recursion. First, let's compare using loops. First, which is either implemented in the main function or using a separate function. Both the programs are on similar lines. They accept the user's input and store it in a variable. This variable is then passed to a user-defined function. The loop is used to implement the main logic here. The only difference between the two programs is that the main logic is transferred to a user-defined function. Let us focus on the main logic and try to understand how it works for finding the factorial of 4. The for loops counter C is initialized to 1. Then the test condition is checked if true. Then the statements within the loop are executed. Initially, as C is 1 and 1 is less than equal to 4, so the value of fact is changed, after which the counter is incremented. Then again the test condition is checked now, as 1 is less than 4, so the new value of fact is calculated. Again the counter is incremented and tested. As 3 is less than 4, so fact is recalculated, and counter is incremented to 4, and test condition is evaluated. As it is true, new value of fact is calculated and counter is incremented, after which the test condition is tested. As phi is not less than equal to 4, so its result is false and the control jumps out of the loop. The result is stored in fact variable, which is 24. Now let's study factorial using recursion. Focusing on the main logic, we reach on if condition. As we can find factorial of only positive numbers, so negative numbers are not allowed. If the number is positive, then we call the factorial function passing it, the number, as an argument. Let's see what happens in the function then. We find out factorial of 4 using it. N is assigned 4. As 4 is not equal to 0, therefore control jumps to else part, where again a call to factorial function is made and the argument passed is 4 minus 1, which is 3. Again the factorial function is called and if part is ignored. In the else part, the control goes to factorial again with 2 as the argument. Again, the if part is ignored and else part is executed with a call to factorial with the value 1. Again, if is ignored and else is executed. The factorial function is called with 0 as argument. But this time if condition is true, and so 1 is returned to the previous call. As 1 into 1 is 1, so 1 is again returned to the call before this. Now 2 into 1 is 2. This 2 is returned to the previous call, which gets multiplied with 3, resulting into 6. This 6 is returned to the first function call here, 4 is multiplied by 6, and 24 is returned to the main function. Thus, the factorial of 6 is 24. Now, if we compare 3 methods, we realize that the answer remains same for all the 3 methods, but recursion is the best way out of all the 3 as it is simple to implement. Let's learn to pass array to functions. Like the variables, it is also possible to pass an array to a function. To pass one-dimensional array to a called function, it is sufficient to only list the name of an array without any subscript and size of the array as arguments. Here A is any array and n is its size. The called function should be appropriately defined in this manner. Here the pair of brackets informs the compiler that the argument array is an array of numbers. The size of them need not be necessarily mentioned. Look at this example. Here the array C is passed onto array A in the function call, while in the printf statement only the first element of A is printed. 3 rules for passing an array to a function. Function must be called by passing an array name. Function definition formal parameter must be array type. Size of array is not needed to be specified. Function prototype should show the argument is an array. We can also pass multidimensional arrays to function. This approach is similar to one-dimensional arrays. The rules are: function is called by passing an array name. Function definition formal parameter must have 2 brackets. Size of array is needed to be specified. Function prototype declaration is same as function header. Lastly, we learn passing strings to functions. Strings are treated as character arrays in C. So the rules of passing string is very similar to that array. Basic rules are: the string to be passed must be declared as a formal argument of the function when it is defined. The function prototype should know that it is a string. The call to the function must have a string name without the subscripts. Let's have a quick review of what we've studied in this lecture. Function is a module or block of program code which deals with a particular task. The need for writing a user-defined function is that they lead to modular programs and also increase reusability. Usually, a program should be divided into a number of functions so that each task is divided into an independent function. A user-defined function consists of a function header and the function body. The header consists of the return type, name, and the argument lists, while the body consists of local variable declaration, execution statements, and return statement. The type of function is determined by the value it returns to the calling function. A function is called by simply using the function name followed by a list of actual parameters, if any enclosed within the parentheses. A function declaration, function prototype, consists of 4 parts: function type, function name, parameter list, terminating semicolon. Let's learn the various categories of functions. Category 1, functions with no arguments and no return values. Category 2, functions with arguments and no return values. Category 3, functions with arguments and 1 return value. Category 4, functions with no arguments but return value. Category 5, functions that returns multiple values. Recursion is a special case where the calling function calls itself. To pass one-dimensional array to a called function, it is sufficient to only list the name of an array without any subscripts and size of the array as arguments. Example, largest A n. The approach of passing a two-dimensional array to a function is similar to one-dimensional arrays. Strings are treated as character arrays in C. So the rules for passing strings is very similar to that array.